This video is going to be a discussion of the SA1 practice set number 2 open-ended questions. Alright, so we're going to start off with the first question, which is question 29. You're given 3 substances and it shows the freezing and boiling points. So let's just recap. When it comes to freezing, we are talking about things that changes from liquid to solids. Okay, whereas when we talk about boiling, we are talking about like boiling water, and the boiling water started off with liquid and how it becomes water vapor. That's why you see all the smoke that comes out when you boil water. It changes to gas. Alright, so now we're at 200 degrees Celsius. What is the state of P and Q? So we're going to start off with P first, and we will have the freezing point 110, boiling 180. Now, when I would like you to think of these numbers as being placed on a number line. Okay, now the number line is from the number smaller, it gets bigger and bigger, 180 all the way, and it gets bigger. So where do you think you will park this digit 200 at? You will most likely park it here, right? Because it's a number that's bigger than 180. Now, since it is a number bigger than 180, that means it has gone beyond the boiling point. The things must have already boiled. And if it has already boiled, that means it has already turned to a gas. So P must be a gas. Let's take a look at Q then. Now we focus on Q. The same method goes. We park all these numbers as though they are on a number line. And where is the digit 200 going to be at? 44 is here, 280 is here. So 200 will be somewhere in the middle. Alright. Now if it is the middle, that means it has gone beyond the freezing point already. Okay. But it has not passed through the boiling point yet, which is 280. It is still at 200. That means technically it has not boiled. It is in the process of boiling, maybe. So it is still not a gas, but it must be a liquid. Okay? It cannot be a solid because for it to be a solid, it must be lower than 44. So it must be a liquid in this case. Alright, so that is for the answers of part A. Now you have got a fourth substance, and this substance we're going to call it S, according to what they said. And it is a solid state at 50 degrees. It is a solid state at 50 degrees. That means it is most likely here. Alright, it has already frozen at 50. And in the liquid state at 90 degrees. That means from here, S is most likely going to be something above 90 for it to be boiling. So perhaps 91. Because at 90 it is still a liquid. Alright, at 90 it is still a liquid, so it hasn't boiled yet. So perhaps the boiling point could be at 91. We don't know. Alright, now we are going to look at it in terms of arranging from the lowest to the highest melting point. Now let's recap what is the meaning of melting. When ice melts, it melts when it is changing from liquid to a when ice melts, it melts from a solid to a liquid. Correct? So we're going to arrange them in a form of something like our freezing point like that. So the lowest melting point will have to be Q, right? Looking at the numbers all here. Q is only 44 for it to freeze. So Q must be the lowest melting point. And then looking at the data, next will be S. And then following on will be P. And then you have got R, which is the next highest one. Alright, so this must be the arrangement for the melting points. Okay, now we're going to skip question 30 because it's semester 2. And we're also going to skip the next page on theme. And we're also going to skip the one on condensation, which is on question 31. And we are going to go to question 32. Alright, now question 32 is an electricity topic. So you have got an experiment. What happens is that you have something like a blank here. Okay. And this blank, you are going to put some rods over it. And by putting X, you notice the bulb didn't light up. By putting Y, the bulb didn't light up. But by putting a rod Z, you notice that the bulb actually lighted up. So when they ask which rod is going to be a conductor, the choice definitely has to be Z. So this gives you 1 mark. Or the choice is correct, not yet. You still got to explain, because I realized the total mark is only 1 mark. So what is the reason? Again, when you have to explain, remember, you have your choice, you have the evidence from the question, from the results, as well as what happens to the result because of the evidence. Okay, so the choice must be Z. And the evidence is why so? The evidence is that the bulb lighted up, right? And why is it that the bulb could light up? It must be because electricity flows through, right? So you have got a sentence over here, ZY, because it allows electricity to pass through. And then you have the word so, this is the result, the bulb could light up. That is the result of it. So if you have an explanation question, remember to make your choice correct. Remember to also connect with the so part. So what happens to the results? Because of the evidence you raised. Okay. In another experiment, some wax was placed on top end of the 3 rods, and the 3 rods were placed on a hot surface as shown. So this is a hot surface. Heat is going to travel. Heat is going to travel from a hotter to a colder place, right? And this experiment sounded very familiar, right? Something that we have done in primary 4. And it realized that Z melted first. This one was the one that followed first. Then this is next. And then this is the last that melted. So what does it tell you about the heat conductivity? Again, make a choice, right? You have to make a choice. And because you're comparing with 3 different rods, okay, you are comparing with 3 different things. The only comparison word that you can use is best. You cannot use the word better because better refers to only 2 things. So Z is a best conductor, and then of course because you are comparing against 3 different things, you also have to talk about the other 2, followed by X and then Y. If you stop your answers by only talking about Z, okay, you will not get a full marks, because a comparison requires you to talk about all the things that's been compared. So you got to talk about, alright, if I could highlight, you will have to talk about Z, okay, you will have to talk about Z, you will have to talk about Y, okay, and you also have to talk about X. Alright, talk about 3 things. Okay, from your answers A and B, one talks about electricity, the other one talks about heat. What can you conclude about the relationship between electricity and heat? Alright, now you have already learned in your lesson that electricity, for it to be a conductor, it must be usually a metal material. And usually a metal material happens to be a good conductor of heat as well. Alright, so the relationship is this, the pattern is this. A good conductor of heat is also a conductor of electricity. Okay, now you notice that I wanted to insert the word good, but I started to erase away the word good. Alright, because for electricity, there is only either conductor or insulator. Okay, let me just write it at the side as notes. For heat, we can talk about good or poor conductor. Whereas for electricity, we can only talk about whether it is conductor or insulator. So you see the differences. There's no such thing as poor conductor of electricity. If it conducts, it will conduct. Alright, it's not a matter of whether poor or good. But if it doesn't conduct, it is insulator. So conductor is like 100%, it will conduct. Insulator is like 0%, it won't conduct. There's no such thing as half-half, right? Poor conductor. So you cannot use the word poor or good when you talk about electricity. So that is one learning point. So yes, a good conductor of heat is also a conductor of electricity. Don't talk about word good anymore. You can only mention the word good when you say about heat. See the difference? Alright, so we go on to the next one already. We're going to move on to question 33. We're going to skip 34. We're going to skip 34. So now we will go on to 35. Okay, now 35 is about a primary 3 topic that you have learned before as well. It is on these little black spots on a bread, but now we're talking about some donuts. So all these black dots are none other than your mole. So these are primary 3 stuff. I'm not going to go through them in details. And why does it get its black dots or black spots? How does it get its food to survive? Now in P3 you will have learned that mole, they feed on what we call as decayed materials or dead matter. Okay, so they feed on all those dead things around them. Now in this case, the mole, where are all the dead things and where are all the decayed materials? They are from the donuts. So where does it get its food from? They basically get its food from the donut. Alright, none other than just the donut, because the donut is the one that provides all the decayed material, all the dead stuff that's providing all the food. So it gets its food from the donut. That's the key word. Okay. Now, next one. What characteristics of living things? You have learned about the 4 characteristics, right? They need air, water, food. And they reproduce. They grow. Grow means they grow in size, right? Not in numbers, And then we also talk about them responding to changes. So 4 characteristics. Now, when we talk about grow, you talk about size. When you talk about reproduce, you talk about numbers. From 1 become 2, 2 become 4, and so on. So when you have an increase in the number, in the amount means number, right? The only characteristics that you can say is living things reproduce. Nothing about growing, in case some of you are writing about grow, because they didn't mention about the size. They mentioned about the amount. So it has to be reproduced, nothing else. Okay, so you have written something like reproduce is a correct answer already. Okay, now question 36. You have got to see how the arrangement is like and how it helps. Alright, now I would say that this is actually a comparison question. Doesn't look very obvious, but why so? Because there can be many types of arrangement. One arrangement is, you notice they are scattered all around. Yeah, they're scattered all around. Alright, versus another type of arrangement is they could be all closed up together. So even though this question didn't explicitly compare the spreading out and the closed up, but they're asking you why is it that this particular arrangement is better. Okay, so it is still a comparison question. So I should see comparison words. So what happens is that how this arrangement helps, when you actually spread out, okay, you notice that the leaves are very smart. When they spread out, what happens is that you notice compared to the arrangement where they are all stacked together and all flooded together, you notice that more, again, you see the comparison word, more leaves will enable more sunlight to be trapped, right? More leaves will get more sunlight. So if you remember in class, I said this, I said that comparison word comes in pairs, so more and more leaves will get more sunlight. And what is the purpose of sunlight? For photosynthesis. Okay, again, I should use the word connector so, because explanation. So they can photosynthesize or they can make food. Okay, so no, 2 comparison words and the word so as a connector. Okay, 36b, simple. And the reason why these plants requires them to grow on a fence because they can't stand upright on their own. They need some kind of a support. And when we talk about support, the word S will remind you of the word stems. So, in all case, that means that when you're referring to this question talks about why they need some kind of fence. It means that because the stems are actually quite weak. So this is what we call as a weak stem. Okay, so I'm just going to write the answers, weak stems. Alright, so this is easy for 36. We're going to move on to 37. Now 37, you have two different materials, and you notice that we place them and you record their mass after every 5 minutes. So it seems that why mass can increase is because the liquids were absorbed. Right? Precisely because they are being absorbed, that's why the mass can become heavier. Right? So now, out of these two materials, you notice two materials, then I know this question must be a comparison question because I'm comparing two things, two pictures given. So Y seems to be, the mass appears to be the same throughout. So what can we already say about Y? It does not absorb water. Okay? Does not absorb water. Whereas it seems that for X, it absorbs. Now, every time when we talk about absorbing, the first thing that you need to think about material, you have to look at properties. Remember, ability to float in water. Remember, transparency. Remember, strength. Remember, flexibility. Remember, waterproof. So when we talk about material, what property is it trying to test you on? When we talk about absorption, we are trying to test you whether you know the property of waterproof or not. Okay, so what can he conclude about Y? Just Y. So we can say that Y is waterproof. Okay, now give a reason why, and the evidence is going to be here already. The evidence is this. The evidence is because Y does not absorb water. This helps to explain why it is waterproof, right? And then a connector. So, what is the result of it not absorbing water? So the mass is the same. Alright? So in every explanation question, give a reason is an explanation. You have to use the word connector, so. Okay, so that's for question 37A. Now 37B, which of the following things should be kept constant? Now, for it to be a fair test, it means that only one changed variable can be made. Okay, if you are trying to see whether which material is waterproof, then you can only change the material, right? Other stuff you cannot change at all. So your length of the strip must be the same, your type of liquid must be the same, your thickness of the strip must be the same. The only thing that will change is the material, right? Because you want to see which material is waterproof or not. So there should be 3 ticks, only one changed variable. In all fair tests, there's only one thing you changed. Okay? So the others must be the same. Okay, now let's look at C. He accidentally spilled some orange juice on the table. Which material should you use to wipe dry? Explain your answer. Choice, evidence, and result. Now, choice must be correct. So, of course, you're going to choose something that is waterproof, right? For it to be waterproof, let's go back to the table. Which one is waterproof? Is it X or Y? Waterproof means it cannot absorb water. But in this case, you want it to be able to absorb all the water from the spill. So you have to choose one that absorbs, right? So X must be the answer. Alright, you're going to choose X because X is the one that absorbs. Why? What is the evidence? Evidence from the results. It absorbs the water. So it is able to wipe the table dry. Now, because you are trying to make a choice out of the other option, so you will need to mention about why is Y not able to be the choice. X absorbs the water, so it's able to wipe the table dry, but Y cannot absorb. So it will not be able to wipe the table dry. Alright, just be a little careful because you are given two choices, you justify both. Why this one is a better one, why the other one is not. So you talk about both X, you talk about Y as well. Alright, that's for 37. Now 38 talks about metal. Alright, now 30 is the volume here, 30 is the volume here, and you are going to have B poured over to A. So 30 plus 30, is it going to give you 60 in this case? Not true. Your water level is definitely going to be lower than 60. So if you have drawn a line that is at 60 or above 60, it's wrong. It must be lower or above 30. It must be lower than 60 but above 30. So your range of answers can be in between the shaded part here. Alright. So what is the reason why? Okay, now when we talk about metal, a few magic words must come into your mind. Alright. Why is it that 30 plus 30 doesn't give you 60? Okay, because you notice there's a lot of empty spaces inside here. So we're going to try to explain that about using occupying space. So what happens when you start pouring in water? The water poured in into A. What has it done? It has occupied, right? It has taken up some space. What spaces are that? The spaces where? Where are the spaces? Among the marbles. So it won't be 30 plus 30 equals 60 anymore, because there are some empty spaces where you can still fill up. So it won't go up to 60, it will be less than 60. Alright, so remember your science terms. So it will not reach 60 cubic centimeter. Alright, explanation question. You have your so part. Okay, occupying the space is the key word. And of course, when you talk about occupying the space, please, in all types of questions, tell me where are the spaces. The spaces are among the marbles. This important part, a lot of people tend to miss out. You say occupy the space in the toy car, occupy the space in the toy duck. But which space? Alright, occupy the space in the toy duck. Occupy the space among the marbles. Between the marbles. Okay, so on. So talk about the where part. Alright, so for part C, easy already. What property have you learned? You have learned that metal takes up space, occupies space. You have learned that it has volume. You learned that it has mass. All these are metal. So you just need to choose. It's nothing to do with mass for this question, right? Because we didn't show a weighing machine. We didn't show a balance. So the answer is metal has volume. Or if you have written something like metal takes up space, that's the same meaning also, because volume means taking up space, by the way. Alright, so this is for question 39. Okay, now question 39, next question. Now if pole C is going to be a north, alright, so this is your guess and check. If it is north, this has got to be south, right? Now if this is south, for it to attract, it must be unlike poles. So all these are unlike poles. This must be the opposite pole. This is opposite pole. This is opposite poles for it to attract. So I've basically listed out everything. Pole A, what would it be? It will be a south pole. You can spell it out as well. You can just write S or you can spell it out. Pole H is also going to be a south pole. Okay, this is quite easy, huh? Alright, now the stroking method. Alright, electrode method. These are all the methods to make magnets. So now you have two poles, X and Y, but you don't know which one is the north, which one is the south. So with a north point of a bar magnet that is given, how can you determine whether which one is the north, which one is the south? Okay, we're going to use the property like poles attract, or unlike poles attract, or the like poles repel properties. So one way, two different possible answers. You can choose either one to write, don't need to write both. I can use the north pole one. So for example, I can bring the north pole of what? Of the magnet, and I take this north pole to either X or Y. Choose one side. If, of course, you got to talk about the results, right? You have to tell the kid, hey, you want to test, you have to tell me what results do I need to observe. So if the pole, or if the sides will repel, you're bringing the north to one side, and if it repels, that pole must be north also, right? Because like poles repel. Okay, now you can also talk about the opposites. You can say, oh, if I bring the north pole of the bar magnet to X or Y, and if the pole attracts, then you know that pole must be south, right? The opposite pole, right, must be south. So you can either write one or you can write both. Alright, my suggestion, just one will do. Alright, choose either one. No need to write both, because already if attract, I already know that it is an opposite pole. Okay, so you don't have to write two different versions of the answer. Okay, now question 40. So you have got a torch, and then you have got a material X. You're trying to move towards it, and this is like your eye, So of course your eye with holding on to the torch. So this person is going to be walking towards the material. Now, how does one person sees things? The light source points and then reflects back to the person's eye, right? So of course, the person will have to record the distance at which the reflection starts taking place. So different materials were tested. It seems that you look at this now, this one, T, seems to be able to be seen from the furthest distance. So what does it tell us? It basically tells us it is able to reflect light from the furthest. Okay, so if you can recall, there's this very popular question about people wearing safety vests. Alright, if you want to choose a material where you can see from the furthest, T will be the best material because it can reflect light. You're able to see from the furthest distance away. Alright, so this will be the best material for making a safety vest. But anyway, what was he trying to find out? He was trying to find out which material. Okay, because there were 4, right? He tested with 4. So he was trying to find out which material can reflect light from the furthest distance. Alright, because he used the results, the distance. So I think he will want to use some of the conclusion based on the distance. So the word distance must be there. Alright, and of course reflects, because we're talking about reflection, lights, and shadow, we talk about reflections. Okay, so these two keywords must be inside the answer. Okay, so explain why Ming Han could see materials S when he was 290. Why was it that he was able to see it? Okay, already at 290, because at 290 there was some reflections going on already, right? So why was it able to see? Because X reflected enough light already. Alright, there was already enough light. If there wasn't enough light, like in the dark, you won't be able to see anything, right? So precisely because there were already enough light reflected, okay, at 290 degree meter, that's why he could already see. You can only see things when lights are reflected to your eyes. So there was already enough light. If there wasn't enough light, you won't be able to see at all, isn't it? So that is the answer for B. And for C, based on Ming Han's result, which one will be a safety vest? This one I talk about. So we make a choice, T. So you compare, right? You are comparing with three things. Again, when you compare with three things, what are some of the words that you use? Best, furthest, clearest, and so on. So these are all the words that you must remind yourself to put in. So why chose T? Because it reflects light from the furthest. Again, my comparison word is out. And then we have to go on to the so part already. So it allows people to tell me now the results, right? Remember your choice, your evidence, and your results. Results. So it allows, so let's put a CER. We have done the choice. Evidence is the table showing the longest distance, and the results, we're going to say it now. So it allows people to see the vest, the clearest. Again, comparison word comes in pairs. Furthest, so you allow it to see the clearest. Alright, so that is for 40. And we go on, 40D now. Now 40D, Ming Han experimented. You use a brighter torch light. The distance, will it be longer, lesser, or still 300? Now of course, when you have more light, small amount of light, you're able to see it from a further distance, right? It's able to reflect enough, more than enough light. So of course, the distance will be more. Alright, because you can see now from even further distance. Alright, now someone suggested using a light sensor. Now a light sensor is going to give you numbers, right, in terms of lux, the amount of light. So how does it help to improve? It basically makes the results more accurate. Okay, so the keyword here will be the word accurate. That is for part E. Okay, now last question, question 41. Okay, 41, you have got a metal, you have got a glass, and hey, you have got an air. So it seems like this question is going to test out our poor conductor of heat again, right? So why is it that in A is likely going to cool down quicker than B? Now you are comparing with how many things here? Comparison question. Now two things. So I write this down at the side to remind myself. Two things, what kind of words do I use? Why is it that A is going to cool down faster? Why? A is a better conductor of heat, right? Because it's metal, of course it's better conductor of heat. Now what do you understand by conductor of heat? It means it gains heat faster. Now if it gains heat faster, it's also going to lose heat faster. So quick revision, when you say things like gaining heat faster, it also means that you will lose heat faster. Alright, so that is fair, right? You gain heat faster, you lose heat faster. You gain heat slower, you lose heat slower. When you say that A is a better, why better? Because you compare against B, right? It's a better conductor of heat, so what happens? It's going to gain heat faster. It's also going to lose heat faster. So it cools faster too. Okay, so your comparison word better and faster. Comparison word in pairs. Alright, and also the connector so. Alright, let's go on to B. Explain why mark C is likely to keep the drink warmer. Now, C has a special characteristics, right? C has air. So, and we know that air is a poor conductor of heat. Alright, now when it is a poor conductor of heat, what happens? It's going to lose heat slower. So where are the two comparison words? Poor, slower. And when you lose heat slower, you need to tell me you lose the heat to where? To the surrounding. Please always tell me where. Alright, now if you remember, you talk about metal just now earlier. We want to talk about where also, right? Where is it occupying the space? You talk about heat, you also want to talk about it gains heat and it loses heat to where? Or gains heat from where? From the candle, from the fire, from where? So the word where is very important. You have to mention where is the place where the heat was gained or lost. Where? This is the where part. Okay, last question. Same idea, you still have got the air. And why is it able to keep people warm in winter places? Similar answer. Air is a poor conductor of heat. And what happens? Heat gain is slow, right? Heat loss also slow. And when heat loss is slower, and where again, where? Again, I have to emphasize this all the time. Where? Your heat loss goes to where? Heat loss is slower. Heat loss to the surrounding, right? To the surrounding is slower. So it keeps people warmer for a longer time. Okay, so you have the word slower. Okay, you have got the word slower, you have got the word longer. Comparison word comes in pairs. Alright, so we will see you back in school with your examinations. Just remember all the techniques you have learned for open-ended questions, and good luck.